Hello, in this video we are going to solve a complete problem by sketching a polynomial function from beginning to end. So let's see our example problem we are going to sketch. So function of x equals 6x cube plus 13x square plus x minus 2. So we are going to sketch this function. Okay, so let's follow step by step. All right, so first of all we let's look at some properties. So this is what a third degree polynomial, okay, because this is highest power is 3, so n is equal to 3. Okay, so let's keep that in mind. Okay, now first we are going to try to find all the real zeros. All right, so let's look at find real zero, find all zeros. Okay, that is our objective. Now if I may, which we did in a previous example, so as you can see in this example we have in this example we have function of x equals this function, and we need to find all the real zeros. So what we did, first of all we try to find the number of positive zeros using Descartes' rule of sign, and then we try to find number of negative zeros, and then we write down all the possible rational zeros, and then we basically test one by one, like function of 1, function of 2, function of 4, 8, 1/3, so on and so forth, try to see which gives remainder 0. So and then we did the synthetic division, and then we find all the real zeros. So that is the exact procedure we are going to basically follow for our this particular problem. So let's find out number of positive zeros. Okay, so number of positive 0 using the Descartes rule of sign. So for number of positive 0 we need to see the variation of sign in function of x. So what is how many variation of sign in function of x? I have only 1, so I can have at a maximum 3 real zeros, sorry, 1 real positive real zeros. Okay, so what is so to find out number of negative real zero, I need to first find what? I need to find function of negative x, and to find function of negative x I need to flip the sign of odd power term, and so it is going to be negative 6x cube positive 13x square, and positive x is going to be negative x, and that negative x is going to be same. All right, so how many variation I have here? 1, 2 sign variation. All right, so number of negative, so number of negative zeros, negative 0 will be how many? 2. Okay, so so I can have 2 negative real zeros, and I can have only 1 positive real zero. Okay, so let's now find out the all possible rational zeros. Okay, so all rational zeros, all rational 0 we find it by what? P over Q, and P is factors of that constant term which is negative 2 over factors of this term 6. Okay, factor of 6. So let's see. So factor of negative 2 is plus minus 1 and plus minus 2, and factor of 6 is plus minus 1 plus minus 2 plus minus 3 and plus minus 6. All right, so if I write down all the rational zeros, all the possible rational zeros, I find it plus minus 1, plus minus 2, plus minus half, plus minus 1/3, plus minus 2/3, and plus minus 1/6. So these are my all possible rational zeros. Now I'm going to try to test one by one. Now which one I'm going to start first? The negative one. Remember, I can have two negative real zeros. Okay, so so let us try to test the negative one first. So I'm going to try to find the remainder. How we find remainder? Function a, and if we find 0, it will be fine. So let's see. Function of -1, function of -2, and then what? Function of -half, so on and so forth. All right, so let's see what is function of a -1. So it is 6 -1 cube plus 13 -1 square plus -1 minus 2, and you are going to find that this is not 0. Okay, let's do function of -2, which is 6 -2 cube plus 13 -2 square plus -2, and if you punch the calculator, you are going to find this is 0. So so that means we can say, so let me erase the other one, so we don't need this one. So we can say now that x equal to -2 is a 0, okay, or that means x minus -2, which is x plus 2, is a factor. Okay, is a factor. All right, so I already get one real zero. So once I get one real zero, then I need to perform a synthetic division. Let's do the synthetic division. So first of all, I need to write my function in descending order, which is already in descending order. Well, let me write down the function again. So which is 6x cube plus 13x square plus x minus 2, and as you can see, this is already written in descending order. Also, there is no missing term, so I am going to simply write down the coefficient 6, 13, 1, -2, and then here I'm going to write down this -2, and I'm going to draw a horizontal line. So my problem is already set up. Okay, so now let's do one by one. So I'm going to take down 6 down here, and then I'm going to multiply by 6 with my this -2. So 6 multiplied by -2 is -12, and if I add these two, I'm going to get 1, positive 1, and then I'm going to multiply positive 1 multiplied by -2, so it is going to be -2. So if I add these two terms, positive 1 and -2, I'm going to get -1, and then I need to multiply -1 with -2, so I get +2. So if I add this 2, I get 0. Okay, so my remainder is 0. Of course, that's what is expected. So let's find out what is my quotient. So my highest power of my dividend is what? X cube. So highest power of my quotient will be x square. And what is the coefficient of x square? 6. And what is the next term? Plus 1x minus 1. So this is my quotient. So now how I can write my function? So I can write my function equals, let me use another color. So my function is going to be equal my quotient, which is 6x square plus 1x minus 1 multiplied by the factor, which is x plus 2. And as I want to find the real zero, so I'm going to equate it equal to 0. So let's see. Of course, x plus 2 is equal to 0, and the other one 6x square plus 1x minus 1 equal to 0. So I get x equal to -2, which is expected, we already know. And then this is what? This is my quadratic function. So I'm going to use the quadratic formula. So what is the quadratic formula? X would be equal to minus b, so minus 1 plus minus square root b square. B is 1, so it is 1 square minus 4a, a is 6, and c is -1 over 2a, so 2 multiplied by 6. So if you punch your calculator, you are going to find x equal to -half, sorry, -half, why I wrote -1/3. So -half and +1/3. So these are my three real zeros. Okay, so one is x equal to -2, so x equal to -2, and the other two is x equal to -half and +1/3. So, okay, so we are done with our real zeros. So now let's follow step by step. Okay, so first of all, again I just want to write down my function so that I don't have to scroll again and again. 6x cube plus 13x square plus x minus 2. Okay, so now step number 1 is AND behavior. All right, so finding AND behavior. So as you can see, my term is what? 6x cube. That is my dominating term. So this is actually similar to what? Y equals x cube. So it is going to behave. So I am going to try to draw my whole function over here. So let me set up my graph paper here, if I may. Okay, now I am going to erase it. So let's say it is here and it is here. Okay, so that is my graph paper. All right, so also another thing I want to point out is I want to also put all my real zeros. So let us see, where is my real zeros. One real zero is where? At -2. So this is my -2. And then another real zero is what? X equal to -half. So x equal to -half is somewhere here. And where is my third real zero? X equal to 1/3. So let's say x equal to 1/3 is somewhere here. Okay, so these are my all real zeros or x intercept. So let me now draw the draw the AND behavior. Now as you can see, my AND behavior is what? Similar to y equals x cube. Now you know, for y equals x cube, the AND behavior in the right hand side, it goes up on the left hand side it goes down. Okay, so that's the end behavior for y equals x cube. Okay, now as you can see, now I can basically extend it for my x intercept. So it is going to come this way, it is going to come this way. I need to mention one thing here, I forget, a multiplicity of 0. So if you see multiplicity of x equal to -1 equal to 1, because it comes only one time. Multiplicity of x equal to -1/2 is also 1, so because it's also come one time. Similar here, it's all come one time. So these are all odd multiplicity. That means what? For all the three cases, it is going to cross the x-axis. Okay, cross x-axis. So that is the reason I am crossing the x-axis for my graph paper. Okay, so so anyway, so we are okay with up until this point. So now, so we are done with end behavior. All right, so let us do the step number 2. Step number 2 is finding x-intercept. Okay, so which we already did, finding x-intercept, and we already found x-intercept equal to -2, -1/2 and 1/3, which is already there. And step number 3 is finding y-intercept. So to find y-intercept, we know that we need to put what? Put x equal to 0. So let's find out in this equation. So I want to find y, which is function of 0. What is function of 0? 6 0 cube plus 0 plus 0 minus 2. So I can say y equals, which is function of 0 is -2. So this is my y-intercept. So where is my y-intercept? So my y-intercept is at this point, -2. Okay, well, let me take down a little bit further down. So let's say -2 is somewhere here. So this is my -2. Okay, so that is my step number 3. Now let's do the step number 4. Step number 4 is use test point method. So use test point method. So for test point method, first of all, I need to divide my axis into the zone. So my first zone is what? -infinite. So -infinite to -2. This is my first zone. Second zone is what? -2 to -1/2. And what is the third zone? -1/2 to 1/3. And my final zone is what? 1/3 to +infinite. So these are my all 4 zones. So let me write down all the zone. So all the zone is what? -infinite to -2, -2 to -1/2, then -1/2 to +1/3, and finally +1/3 to +infinite. So these are my all the zone. Okay, now I am going to actually choose some test point from each zone. Okay, so test point. So from the first zone, let's say I choose a test point -3. Okay, I am choosing a test point -3. So x equal to -3. This is my first test point. Let's say from the second zone, I am choosing a test point -1. So I am choosing in test point x equals -1. And then for the third one, I am going to choose a test point x equal to 0. So x equals 0. And from the fourth zone, I am going to choose a test point x equals +1. So I am going to choose x equal to +1 for each test point. All right, so now let's what is the last step? finding the sign for each test point. So find the sign of function of x. So let's find out. So function of -3, I need to find the sign of function of -1. I need to find the sign of function of 0, and I need to find the sign of function of 1. Right, so let's formulate function of -3, so which is what, 6x cubed 13x square plus x minus 2. So it is 6 multiplied by -3 cube plus 13 -3 square plus x, which is -3 and minus 2. Okay, and then for x equal f function of -1, so it will be 6 multiplied by -1 cube plus 13 -1 square plus -1 -2, and function of 0 we just saw it is -2, and function of 1 the same. Okay, so now I am not going to waste time here, so just want to write down the sign only, because we don't care about the numerical values of this. So if you punch the calculator, you are going to find that the first one, the sign is negative. Okay, so it is negative, so that means it is negative. So my graph need to be below x-axis, so which is already there. For the second one, if you punch the calculator, you are going to find that it is going to be a positive sign. So that means for the second zone, my graph need to be above x-axis, so that means it is going to be connecting like that, so it is always above x-axis. My third zone, as you can see, it is negative, so it is negative, so that means it need to be below x-axis. Remember, not only it need to be below x-axis, but also it need to cross the y-axis at y equal to -2. Okay, so that's good. And then third one, it will be positive, so it is positive here, so it is above x-axis, which is already is. So this is basically the final drawing of this sketch of this particular graph. So I hope you understand, and that will be end of this section. Okay.